Have you ever found your brain just stuck? Like stuck on a worry, replaying some conversation for hours on end? Well, it turns out that's not some kind of flaw in your thinking. It's actually a biological process. In this explainer, we are going to break down exactly why our brains get caught in these thought loops and explore the incredible science behind this unfinished business. You know the feeling I'm talking about, right? It's that mental hamster wheel, that one thought just will not let you go. Maybe it was an argument or a tiny mistake you made at work or some big decision you're wrestling with. This is a super common experience, and today we're going to give it a name and really understand the fascinating mechanics going on behind the scenes. So the official term for this whole thing is residual strain. I love this definition. Think of it like the ghost of an unresolved problem that's just haunting your neural pathways. It's your brain's internal alert system saying, hey, there's a file left open here. A task is incomplete. We need to close this loop. All right, let's get right into the brain's unfinished business. Because this isn't just random mental noise. Residual strain is actually a pretty structured process. It's like a type of biological work that just hasn't been finished yet, and it follows a surprisingly predictable path. So this basically maps out the entire life of a problem inside your head. It all kicks off with initiation. That's the moment your brain first flags that something's wrong. Then it builds up to a climax, and that's that intense, urgent feeling you get when you know there's a problem, but you have no clue how to solve it. The only way out is through resolution, and that only happens when your brain comes up with an action plan that feels complete enough to finally let it go. Now, to really get how this all plays out, you have to meet the team working inside your head. See, it's not just one part of your brain doing all the heavy lifting. It's more like this dynamic trio of systems, and each one has a very specific job to do. Okay, first up, we've got the sensory brain. Let's call it the analyst. Its entire job is to gather the data. It's building a picture of what was seen, what was heard, what was felt. It's just answering that one fundamental question. What are the facts here? Next on the team is the limbic system, and this is the appraiser. So this system takes all that raw data from the analyst and asks the really crucial follow-up question. Okay, but does this matter to me? How does this mess with my goals or my safety? This is the part that adds all the emotional weight, and honestly, this is where that feeling of strain really starts to fire up. And finally, rounding out our trio is the motor brain, our action planner. Its job is to take the facts and the feelings and figure out a way forward. It's constantly asking, all right, so what are we going to do about this? This is the system that's responsible for cooking up the plan that can hopefully, finally, get rid of that residual strain. So, we've met the team, but why do they get so stuck sometimes? Let's dive into the actual rules of the game, the core mechanics that really explain why some problems just seem to linger forever while others get solved in a snap. Okay, this right here is an absolutely crucial distinction. Your sensory brain, the analyst, it holds the story, what happened. You can talk about it, you can describe it, you can analyze it all day long. But the motor brain, the action planner, it holds the action plan, the how to fix it. And this is why you can know everything about a problem and still feel totally, completely stuck. Knowing the story is not the same thing as having a plan. So all this unfinished business literally exists in your brain as active neural loops. I mean, how perfect is this analogy? It's like an email that's stuck in your outbox. The system just keeps trying to send the message. It's trying to complete the action over and over and over again. That constant looping activity, that is the feeling of residual strain. So how does your brain manage this? Well, it uses a process called the zip-in, zip-out cycle. When you start thinking about a problem, a specific circuit zips in. It powers on to get to work. Then, when you make a little progress or find a solution, it zips out, powering down and letting all that mental energy just fade away. It's this constant rhythm, right? Engage, disengage. And this explains so perfectly why some problems feel so heavy and others don't. If you have fast zip-out cycles, you process things super efficiently, and the strain stays low. But when you have slow zip-out cycles, when those brain circuits stay powered on, just looping and looping without making any progress, that's when you feel that high residual strain. The problem is literally lingering in your circuits. So what happens to all this unfinished business when we finally go to sleep? Well, that's when the brain's night shift clocks in. Yep, sleep, and especially dreaming, is this really special state where your brain completely reconfigures itself to start tackling the toughest cases in its backlog.
This slide is just fascinating. It shows a complete flip in how your brain operates. See, during the day, your brain is mostly run by the left hemisphere, using fast cycles, and it's focused on suppressing strain so you can get stuff done. But during REM sleep, the right hemisphere takes over. The brainwave cycles slow way down. Your mental state becomes way more associative and emotional, and, here's the key, residual strain is highly expressed, not suppressed at all. It's all let out. So all that weird, bizarre, nonsensical stuff that happens in your dreams, it actually has a profound purpose. Your brain is literally taking fragments of your unresolved problems and emotional conflicts, and it's mashing them together symbolically, trying to find creative new connections and solutions that your logical waking brain would probably just dismiss. But what happens when even the night shift can't clear the backlog? What happens when that residual strain just doesn't get resolved day after day? Well, it starts to pile up, and that has a real long-term cost. You can think of accumulated strain like running way too many programs in the background on your computer. It just slows everything down and reduces your brain's overall efficiency. Over time, it can even create what's called a functional injury, where your neural networks get more rigid and less flexible. This is exactly why a tiny, minor trigger can suddenly unleash this cascade of old, mixed-up feelings. And ultimately, it can make us a lot more vulnerable to things like anxiety and mood disorders. Okay, let's bring this all back together. What this model really gives us is a powerful new map for understanding our own minds. It's a way to see our mental clutter not as some personal failure, but as a biological process that has clear rules. And the amazing part is, the science is getting so close to actually seeing it in action. So that's the million-dollar question, right? Is this all just a cool theory? Or can we physically point to this unfinished business in the brain? Well, the really exciting answer is that scientists have very specific predictions for where to look and how to find it. And this isn't science fiction. Using tools like fMRI, scientists are predicting they'll find hyperconnectivity, basically overly strong connections in the brain's emotional loops. With an EEG, they expect to find the signature of those slow, high-amplitude brain waves that match up with the slow zip-out cycles. They can even use something called DTI to map the brain's wiring and see how efficiently strain should be resolved in a particular person. It makes this abstract idea of strain something real, something tangible and measurable. And that brings us to what might be the single most important takeaway from all of this. The next time you feel that mental loop, that worry you just can't shake, remember this quote. Residual strain isn't a flaw in your character. It's not a sign of weakness. It is simply unfinished biological work. Your brain is just trying to do its job. So I'll leave you with this to think about. If we know our brains are carrying around the weight of yesterday's unresolved issues, how might that be coloring the way we see the world right here, right now? Understanding the process, that's always the first step to managing it.